and Master in Science degrees from the University of British Columbia and a PhD in clinical biochemistry. He is also one of the 3 founding directors of the CSCA, which is the Canadian Scientific and Christian Affiliation. Dr. Osmond's extracurricular activities include being a lecturer for the Sir John M. Templeton Foundation in the areas of science and faith. And he has written on topics and participated in many radio and television programs, and for such contributions has been listed as the who's who in theology and science. And so I'll turn this evening over to Dr. Dan Osmond. Thank you very much.
Let me add my welcome to Steve's. It's so gratifying to see so many of you here. And I would especially like to commend Steve and his colleagues whom I've met over supper for arranging this occasion, because there's a great need for awareness at the science-faith interface. In order to perhaps illustrate my statement, I can say that I have moved from the elevated heights of the U of T campus in downtown Toronto into the hinterland. And in the hinterland, we have a phenomenon of very small, struggling churches of the mainline denominations, where there are no young people, essentially, this is a generalization, to get into discussions of this sort, and perhaps not much inclination. It's more a case of survival than getting into these interesting and important topics. The young people, where they are generally in the non-denominational, especially the Fellowship Baptist and the Pentecostals. And there I have found, to my surprise, that the young earth and anti-evolutionist, creationist view is very firmly entrenched. So, putting it very simply, the young people are in churches where the kind of topic and the way it will be discussed tonight is essentially non-existent. So you can imagine that when they reach the campus, and be it in, I think, especially in the biological sciences, where issues of evolution, etc., are very firmly established, they run into a kind of a tsunami of contrary opinion to that which they were raised with at church. So the two authorities collide. The authority of those who taught them at church and the way they understand Christianity on the one hand, and the authority of their professors on this campus and on just about any other, certainly major university campus, which is very much to the contrary. And not surprisingly, we then have the phenomenon of what has been called by the Evangelical Fellowship of Canada the hemorrhaging of faith. Hemorrhaging of faith. It's a report. Google it under EFC for Evangelical Fellowship of Canada, or just hemorrhaging faith, a report put out just a few years ago that reports at a frightening degree of attrition. So think of it. The few young people in many of the rural churches anyway, and I think it applies elsewhere, are in churches where they are taught a particular way of looking at science and faith. And I'm not here to argue which one is correct. I'm simply reporting the reality of it. And what they are taught then puts them in a collision course with their scientific disciplines on campus. And I believe that while we cannot prove that this is necessarily the major cause of hemorrhaging faith, I would venture to say from experience, I've been on this campus as student and faculty since 1960, with a brief time away in the States to work on some special research projects. And I've had students weeping in my office. They're saying, I think I need to give up Christianity, but it hurts me to think that way. So what do I do? And then you just get into some of the explanations that I hope we will hear today. So much as I commend Steve then for, and his colleagues for putting this on, I don't commend him for choosing me as a moderator. And the reason is rather simple. We have three distinguished speakers, but they speak from very different perspectives. Physics, astrophysics specifically, and more, I don't know quite how to define Tom's. Biology, shall we say? Sociology, and then a theologian, a distinguished theologian of this college. And what I couldn't see, and told Steve right from the start, I couldn't see how I, as a moderator, was going to be able to ride these three horses, so to speak, and make it all come together. So hereby notify our speakers that I'm going to depend on you to build the bridges, and I will try to direct some of the traffic. So without further ado, you're going to introduce the speakers, or do you want me to? Okay. Barth Netterfield is a Canadian astrophysicist and a professor in the Department of Astronomy. I think I'll introduce them all, and then they can follow each other. In the Department of Physics at the U of T, he's a leading expert in the development of balloon-borne telescopes. These are astrophysical experiments that are lifted into the stratosphere by high-altitude balloons where they conduct observations that would be hindered by atmospheric interference if done on the ground. I won't read the rest of it, it's long. I heard him, a fascinating talk at the annual meeting of the Canadian Scientific and Christian Affiliation, which this year met in Hamilton at McMaster University, along with our senior group, the American Scientific Affiliation, a very illustrious and fine group, and the British Christians in Science group. And it was a wonderful, well-attended meeting, and Dr. Netterfield gave the talk at the banquet, and he got very animated and uncontrollable, and we'll see what he does. We'll see what he does tonight. I won't read the rest. I can assure you that his credentials are excellent. And if you want the details, I have these notes here. Tom is a lecturer in the history of religious thought at the University of Queensland. He holds a DPhil from the University of Oxford, where he investigated Darwin's skeptic media in the contemporary evolution wars. Tom also has an MA in religious studies from the University of Calgary and a BSc in biological sciences from the University of Alberta. Primary research interest in religion, science, discourse, which we're going to hear about today. And finally, Ephraim Radner, who in this college and in this room really doesn't need much introduction, is a professor of historical theology at Wycliffe College, University of Toronto, holds a PhD from Yale. Prior to his appointment as professor of historical theology, Reverend Dr. Radner was rector of the Episcopal Church of the Ascension in Pueblo, Colorado. His range of ministerial experience includes Burundi, where he worked as a missionary, in Haiti, inner city, Cleveland, and Connecticut. He has taught at seminaries in Connecticut and Colorado, prolific author. Among his works is the book, The World in the Shadow of God, an introduction of Christian natural theology, which he published in 2010. So please welcome our three speakers, and they'll speak in the order they were introduced.
Well, welcome. So, does the universe point to a designer? Well, it's a question a lot of people ask these days, and people have been asking that question for a long time. So, I'm a physicist, so I'm going to start talking about the universe first, and we'll get on to the question. Is this not working? Okay, there we go. All right, thanks. So let's start talking about the universe first, and then we'll get on to whether or not it points toward a creator. Sound good? So, actually, I'm an astrophysicist. You don't like this mic? I hear myself. That's it. How does it come and go? Okay, I'm going to keep going. All right, so the first thing that you notice about the universe, if you start looking at the universe is really, really big. So let's talk just a little bit about the size of the universe. We want to try and get an idea of what we're talking about before we decide whether or not it points to a designer. So the universe is really big, too big to imagine, so we're going to try and make it smaller, just so we can wrap our heads around it. We're going to shrink the universe by a factor of 10 billion, okay? So we're going to think about a scale model of the universe in which the sun has been shrunk down to the size of a large grapefruit, like so, okay? You're picturing the universe now? Sun's that big. The Earth in this scale universe, how big do you think it is? It's one of those little cake decorations, you know, about 1 millimeter across, right? And it's around 15 meters, kind of back of the room, and it orbits the sun. And there's actually 8 planets, right, because Jupiter got demoted. Mercury, Venus, Earth, and Mars, they're little cake decorations. And you got Jupiter, Saturn, Uranus, Neptune, they're kind of larger. The furthest of the planets is Neptune in our scale universe, where the sun's this big. How far away is Neptune? It's about a half a kilometer from here, okay? And that's the furthest of the planets. And what's in between here and there? Well, there's the asteroid belt, which is you take one of those cake and crush it into powder, and then go out, you know, maybe, I don't know, 20, 30 meters from here, and then make a disk all the way around the Earth, the sun. Okay, so really, really empty. Like you can't actually see the asteroid belt if you were there. You just say, this is empty like everywhere else. Okay, so that's our solar system. Got the sun, got the 8 planets. Of course, the sun is not the only star in the sky, right? There are other stars in the sky. Stars are just suns, right? Can you remember that? The nearest star to the sun is where in our scale model? It's on the Alaska-Yukon border. Okay, so what's in between here and there? Saskatchewan? I mean, nothing? I like Saskatchewan. I went there. Say what? The Oort cloud? Oh, yeah, that's a little bit out there, but we'll ignore that. The Oort cloud is like another asteroid belt, and it's sort of like a few, 50, 100 kilometers from here. But all right, so we've got our star, and we got the star on the Alaska-Yukon border. And of course, those 2 stars aren't the only stars in the sky. If you've been outside the city, you maybe have seen the Milky Way at night. I think probably, hopefully, everybody here has. In my Astro 101 class of first years, most of them have never actually been outside the city and seen this, which is really sad. So what is this? This glowing, this glowing stuff here, that's actually a cloud of stars, individual stars. 100 billion stars, 200 billion stars, forms the Milky Way galaxy. Space like this. We have one here. We have one in the Alaska-Yukon border, and then 100 billion more, or 200 billion more. So we're trying to get a picture of our universe in a size we could manage, and now we're lost, right? Because I can't picture how big something is when you have 200 billion of them spaced, one here, one in the Alaska-Yukon border, one in South Africa, and then 200 billion more. So the universe is ridiculously, ridiculously big. Well, actually, our galaxy is ridiculously, ridiculously big. Of course, our galaxy is not the only galaxy in the sky. This is the nearest one to the Milky Way. It's called Andromeda. It's another cloud of a couple 100 billion stars. If this was the Milky Way, we'd live somewhere around here, halfway out toward the edge of the disk, depending on where you put the edge of the disk. Okay? So we're kind of a star, and that's a cloud of 200 billion stars, and wow, it's just nuts. Now, one of the things we do in cosmology is we try and look at the history of the universe, right? Because we don't want to just look at what it's like now. We also like to understand the history of the universe. And it's remarkable that we can do that. And we can do that because light takes time to travel. So let's play this experiment here. Let's imagine in some distant galaxy here, a star explodes. This happens periodically. Stars run out of fuel, and they collapse, and they explode. So a star has exploded here in this distant galaxy. This galaxy is a billion light years away. What's a light year? That's how far light goes in a year, right? So you say, well, how far away is London, Ontario from here? Oh, an hour and a half, 2 hours, right? So how far is this galaxy? It's about 1 billion years traveling at the speed of light. Anyway, the star explodes here, and we have a telescope orbiting Earth, and it's looking at this galaxy, and it does not see the explosion, does it? Because the light is here. So we wait. We wait, I don't know, 300 million years. The star has explosion's gone. We still don't see it because light's on its way. So we wait another 300 million years, still no star, and finally, 1 billion years later, we see the explosion, right? This is great. The farther away you look, the farther back in time you look, because light takes time to travel. We can actually go with telescopes and look at the history of the universe. It's really, really big, but the universe is transparent, so we can look really, really far. So we can look really, really far back in time. So I think this might be the coolest picture ever taken, and I wish I'd taken it. This is the ultra-deep field taken by the Hubble Space Telescope. So what are we doing here? The Hubble Space Telescope is a 2.5 meter camera telescope. And they pointed it out of our galaxy, well away from the Milky Way at some really dark spot in the sky. And they had a really long exposure. You know when your camera, like 60th of a second or something? This is a week exposure. So this is really dim stuff. But that's okay, looking really far away. And what do you see in this picture? Well, you can see galaxies, right? These clouds of 100 billion stars. So we can zoom in, look at those. Okay, yeah, those are galaxies. And no, yeah, those are galaxies. Yeah, and those are galaxies. And everything in this picture is a galaxy. Just remind yourself what a galaxy is. A galaxy is a cloud of 100 billion stars, or 200 billion stars, or some number. Okay? Wow, that's ridiculous. And if you count all the galaxies in this picture, and then figure out how many of these pictures fit on the whole sky, and multiply them, there's about 1 trillion galaxies that would be visible from Earth if you were to spend enough time with the Hubble Space Telescope which you can't, because it's going to, we'll all die long before we'd ever do that. But okay, so the sky is huge, and there's a lot of galaxies. It's big beyond comprehension. Now, something's really interesting about these galaxies. When this was first discovered back in the 20s or so by Hubble, the discovery was that all of these galaxies are moving away from us. And the further away they are, the faster they're moving. So the distant ones are moving away from us pretty fast. The more distant ones are moving away from us even faster. The galaxies in this direction are moving that way. The galaxies in that direction are moving that way. The galaxies in that direction are moving that way, right? They're all moving away from us. Kind of like we're at the center of the universe, which for somebody from Toronto, this is completely natural. Okay, that's interesting. Farther away you look, okay, the universe is expanding? Okay, so it looks like we're at the center of the universe and all these galaxies are moving away from us. Now, if we were to jump onto, say, that galaxy and look back at our galaxy, we would say, oh, look, I'm not moving and the Milky Way is moving away from me. So I'm at the center. So if you kind of imagine yourself in any one of those galaxies, they all think they're at the center. So everywhere's the center. So, okay. What are we doing with this? So we look further away, we look further back in time, because light takes time to travel. The universe is expanding. Galaxies are moving apart from each other. So if we look at the distant galaxies, we discover they're closer together. Right? In the past, things were closer together. So we're looking far away, we're looking farther back in time, to when galaxies were closer together to each other. And so that's why you see things like galaxies colliding and generally carrying on. In the past, things were denser, things were closer together. The universe is expanding, things are moving apart. Cool. Okay. So what are we doing with that? Look further away, look further back in time, the universe was denser. The universe is expanding. If you take a gas and let it expand, it cools. That's how a refrigerator works. Okay? So you let the gas expand and it cools. Let's pretend the universe is filled with gas. Gas is simple, I'm a physicist. Okay? The universe is expanding, so it's cooling. So look further away, look further back in time to when the universe was denser and denser and hotter. Well, the universe is transparent. We can see as far back as we want. There's nothing in the way. Look as far away as you want. Okay? So you look further away, look further back in time to when the universe is denser and denser and hotter. what does really hot gas look like? Really hot gas. Well, the sun. The sun's made of really hot gas, right? That's what it is. The sun is really hot gas. Okay, so I should be able to look at the sky, look behind whatever's in front, look past all the galaxies, all the stars, past everything else, to look far enough away, look far enough back in time, to when the whole universe is filled with hot, glowing gas. And so if you're following my story and not looking at the picture, you would conclude that the whole sky should be glowing like the sun, right? You don't see that, but you see why I might claim that. You might see something like this, okay? So here you are at the center of the universe. You look past all the galaxies until you finally get back to the look farther and further away, look further and further back in time to when the whole universe was filled with a hot, glowing plasma. Now, we don't see this hot, glowing plasma with our eyes, so as one last piece of the story, and then we're going to understand something about the universe. You've heard a fire engine go by? Right? When the source of a wave is coming towards you, the pitch is higher. Source of a wave going away from you, pitch is lower, right? Okay, because light sound's a wave. Well, light's a wave too. So if a source of light is coming toward me, the frequency of the light will be higher. If it's going away from me, it'll be lower. So let's imagine I have a green light, and it's coming toward me at some fraction of the speed of light. Not really fast. Instead of being green, it will get Doppler shifted into blue. And so the green light, if it's coming toward me fast enough, will look blue. Or if it's going away from me fast enough, it'll look red. Red shift, blue shift, that's what they call this. Okay, well, we said the further away you look, the faster things are moving, right? Distant objects are moving fast. Really distant objects are moving faster. This plasma we're looking at is really far away. So it's moving away from us really fast. So originally it was this nice, glowing yellow light or whatever. It gets Doppler shifted to become red light. It gets Doppler shifted further to infrared light. Doppler shifted further still to submillimeter light, and finally microwave light. Infrared light, it's the color of light your eyes can't see, right? You turn your burner up all the way, it's hot, glowing red, turn it down a bit. It's still glowing, but your eyes can't see it. Put your hand near it, you can feel the radiation hitting your hand. It's really giving off a lot of light. Your eyes just can't see infrared light, right? So this plasma, which is glowing with visible light, it's been Doppler shifted to become infrared light, Doppler shifted to become submillimeter light, finally microwave light. So if you build a microwave telescope and you point it at the sky and look at the sky, what do you see? You see this. This is an all-sky map from the Planck satellite looking at this plasma. It's brighter than anything else in front of it. It's the brightest thing in the sky. And so what we're doing here is we're looking at what the universe was like about 13.7 billion years ago. And what was it like? It was filled with this hot, glowing plasma. This has been shifted. Instead of being in this picture, we've kind of cheated, right? Because your eyes can't see microwave light. So if you showed microwave light, you wouldn't see it. Okay, so it's been shifted to become visible light. And then it turns out the early universe is incredibly uniform. And so we've done a color stretch on this thing. So the things that are a bit brighter are now a lot brighter, and things that are a little bit dimmer are a lot dimmer to try and bring out the contrast. In fact, if we just looked at this thing as uniform as it really was, well, I couldn't, because the change in reflectivity of the screen is too much. You can't accurately represent it. It's incredibly uniform. The early universe had to be really uniform. Well, because gravity, now we're getting some fun stuff. Gravity causes things to fall together, right? So where you have an overdensity, like say here, where it's a little bit hotter, a little bit denser, the gravity is attracting everything toward that spot. And places, here where it's a bit darker, a bit less dense, it's being attracted away from there. So densities only grow. Density fluctuations only grow. If you start out with some ripples, those ripples get bigger and bigger and bigger. In fact, the early universe had to start out incredibly uniform. Otherwise, everything would have collapsed into black holes a long time ago. It didn't. It started out incredibly uniform. And we'll get more into that in a sec. So what's really cool, though, is you can say, well, what's this stuff made of? This is plasma. This is hydrogen. It's helium. There's gravity in there. Maybe there's some dark matter. Let's take our physical laws that we understand and calculate what that plasma should look like. how bright should the bright blobs be? How dim should the dim blobs be? You do these simulations, and you come up with a prediction of what it should look like. And then you match it to what it actually looks like, and the agreement is phenomenal. So we can sort of look at this in graph form. This is a, you don't have to worry about what it means, I'll tell you, but you can ignore that. On this axis is how big the blobs are in the sky, and this axis is how bright they are. And what it says is the brightest blobs are about a degree across, and then there's the, there's ones that 0.2 degrees across, they're pretty bright as well, and then really small blobs are not very bright at all. Okay, doesn't matter. What the point here is the red dots are the measurements of that map, and the green curve is what the theory says it should be. And you'll notice that the curve goes through the dots. In other words, we really understand what the universe was doing in those early times. The data and the theory matches incredibly well. We really think we understand what was going on. And it turns out that's true. And you can make some conclusions about what this plasma is made up of. Here, there we go. All right, what's the universe made of? You can conclude from this, looking at that plasma, fitting the models to it. First thing is we discovered the universe is made up of 3 normal matter. That's normal matter. That's stuff you know about. You know, your shoes, dust, gas, whatever. Anything you can smell, touch, feel, taste, normal matter. That's, 5%. Then you get into the big chunk here, the green chunk. It's what's called dark matter. This is stuff that has that gravity attracts, but does not interact in any other way. Right? So you have dark matter streaming through this room, streaming through me. I don't even know it because it can't interact with me, because it's dark matter. It can't be detected any other way so far except by gravity. There are people trying to think of other ways we could detect it other than through gravity, since it's it's a large fraction of the universe's mass. We haven't discovered what it is. There's ideas. Theorists say, well, according to our models, it could be this kind of particle and maybe that kind of particle, but hasn't been identified yet. But it's a lot of the mass of the universe is in this dark matter. Then there's the third chunk here, which here we call dark energy. And this is more or less the best explanation for it so far. We know what it does. It causes the expansion of the universe to speed up. You can think of it maybe as the energy density of empty space. Take a box, get rid of everything, get rid of all the gas, get rid of the light, cool it down to 0 degrees. It's completely empty. How much energy density should it have in there? One might think 0. No, it's 0.7. We're going to come back to that as well. It's a huge mystery. Don't know what this is. Second thing, geometry of the universe. Did anybody here ever take geometry in high school? Excellent. Okay, remember triangles? Some of the angle of the triangles, 180 degrees. Parallel lines, they stay parallel. They don't converge or diverge. All that stuff they taught you? It's only true, it turns out, if the energy density of the universe in total equals a magic number. We'll call it 1 in the appropriate units. Doesn't matter. To some density. If the universe is more dense than that, then all that geometry is wrong. And the sum of the angles of a triangle depends on how big the triangle is. And parallel lines either diverge or converge. And pi is not a constant. It depends on how big the circle is, which is crazy. But if the energy density of the universe equals the magic number, then Euclidean geometry is correct. And everything you learned is fine. You don't have to forget it all. It turns out that the energy density of the universe equals the magic number. That's one thing we discovered. It's really neat. We'll come back to that in a minute too, because that's an interesting fun fact. Last one, what is the age of the universe? Now, that seems like a strange question, right? Because, well, it has an age, it has a beginning, 13.7 billion years ago. Before that, what was there? Well, you have a 0 times infinity. You have that doesn't work. You have a singularity at 0 time. We know physics doesn't work then. Maybe there's no before that. It's not clear. So the universe, as we know it, has a beginning. Historically, that would have been taken as evidence there must be a creator. But now people have kind of gotten used to it. Like, well, maybe the universe just happened. Okay, so this is things we learned from our experiment. So I'm going to switch a little bit now and talk a little bit about physics. just a little bit, just give you an idea. I'm not going to teach you any physics. I'm going to tell you about what you might learn if you were to learn physics. How's that? Physics today is built on two big pillars. There's the pillar of the standard model of particle physics. This is the model, the theory, that describes the behavior of matter and radiation. And you can use it to calculate almost anything to do with matter and radiation. You can use it to, figure out how chemistry works, or figure out, I don't know, what do you want to figure out? Electromagnetism, radiation, nuclear and particle physics. It's really, really fantastic theory. It covers almost everything, and it's incredibly precise. In fact, with one exception, every calculation that's ever been tried with it gets the answer right on, if assuming you do the calculation right. It's a phenomenal theory. It's incredibly successful. So that's the theory of the standard model of particle physics. Maybe you heard last year the big news where they discovered the Higgs boson. It was the last missing part of this model. They found it just where it was supposed to be with just the properties that had been predicted. It's like unbelievable. It's just crazy how good this model is, with one exception we'll get to. The second pillar of modern physics is general relativity. It's Einstein's theory about how energy and matter affect space and time. Said differently, it's the theory of gravity. In this theory, it basically says that gravity is where space-time actually gets bent. And that's what causes gravity. And from it, you predict the existence of black holes, which have been detected. And you predict that light should be bent going around massive objects like galaxies and stars and clusters. And that's been measured as predicted. It describes the expansion of the universe. The universe's expansion follows exactly what it's supposed to do. It's a phenomenal theory. It predicts all these crazy things, but when we go out and measure them, they're there, and they're just like general relativity said they should be. So these two pillars, phenomenal successes. Of course, there's a challenge. The challenge is that these two models don't work together. General relativity and standard model of particle physics are not compatible theories. They describe time differently. They describe space differently. You can't, if you have a situation where you need to know them, when you need to use them both at the same time, you have no idea what to do. This is really hard to come up with places in the universe where this is true. The early universe is one. So we know that that's the one place in the universe we can't calculate things, and that's the early universe. So there's a huge hole in physics today. People are trying to solve it with models like string theory, things like this, trying to. It's a major problem. There's ideas, unsolved problem. Okay, so when we look at the universe, though, this incredibly successful thing, we look at the standard model of particle physics and also general relativity have these constants, these numbers. Things like how heavy the electron is compared to the proton, or how strong this force is to that force. All these numbers. How fast the universe was originally expanding. How uniform the universe was when it started. And there's about 20-some numbers that are seemingly arbitrary. If you start going and tweaking with them, all of a sudden the universe doesn't work. You don't get stars. You can't make water. You can't make carbon. You can't make galaxies. The universe collapses too fast. Everything falls into black holes. It doesn't collapse fast enough. You don't get stars and galaxies at all. You start tweaking with these knobs, and all of a sudden the whole universe doesn't work. This is a problem called fine-tuning. And theoretical physicists, when they're trying to figure out how the universe came to be, have come up against this problem. Namely that, well, the universe seems like it's tuned for life to be able to exist. And if you go online and read about this stuff, people, a lot of rancor over whether or not this should mean anything or not. That's kind of the topic of today. We have this amazing set of theories that really understand how the universe works, but it's got these apparently free parameters whose value can't be predicted, except that the values they have allow us to exist. there's been, people have tried to make solutions to this problem. One of them is a thing called the entropic principle, or the many worlds idea, the multiverse. In this picture, imagine you have an infinite number of universes. Every one has a different set of those values, of those parameters. Some of the universes in your imaginary space here are 12-dimensional universes with this kind of physics and that kind of physics. And some of them there's 6 forces and 12 forces. And some of them has strong gravity and some of them have weak gravity. Every possible universe exists in the multiverse, right? And then you discover that the vast majority of these universes can't support life. And therefore, there are no people in them to wonder why their universe sucks, right? And the only universes with people in them are ones that can actually support life. Making sense? So you say, oh, well, that's why our universe is special. Only special universes can have people. And all the other universes just don't have any people. Sound good? There's a problem. The problem is that our universe is so ridiculously unlikely that it's actually, if you do the calculations, this is a bit controversial, but it seems to be right. The kind of models that you use to try and make these multiverses and stuff end up predicting that there are so many other places in the multiverse that you could exist, that even though, for example, it's incredibly unlikely that a brain would just sort of pop out of nothing in space, there's so much other universes out there, or other times in our universe out there, where brains could pop out of nothing, that it's actually much more likely that you are not actually in this room listening to me, but you're actually a brain that's appeared in space, and it's imagining this moment, and it's about to suddenly discover that it's a brain floating in space and die. Now, it's not supposed to be a real theory. It's supposed to show how ridiculously unlikely our universe appears to be. Okay? Is it making sense? So, it doesn't make any sense, but it doesn't make any sense. So we're kind of in an impasse here, right? We have this universe, it's really special, we really understand what's going on, except for some really major problems. The success is that, well, the behavior of the universe can be accurately described. We really know what's going on. The problem is that if you then try to say that this universe appeared, the hypothesis that the universe at all times and all places is well described by the current physical models, and that the universe came to be like it is purely by chance, faces some really serious problems. We just don't have any models that can actually do that. Well, nobody thinks physics is done. We have this major problem where we don't understand how the two pillars of modern physics can possibly work together. But it's very, very clear that there's something missing. Some people believe that, well, we'll be able to come up with some better models and then show that all these things had to be the way they were. Maybe. Now, speaking personally, I find that, I sure hope we do, because it would be really beautiful. But I'm kind of skeptical. Because if you think of all the things that could possibly be, a lot more of them don't involve me than do. So, I don't know. It's an interesting question, it's an interesting topic. So is the universe consistent with a designer? I don't know actually even how to ask that question. It kind of depends on the personality of the designer. So for me, looking at the universe, we can learn things about God. For sure. We can learn things really powerful. But I think that you can't necessarily use it to show there is a God, because, well, maybe I just don't understand something. So, anyway, that's my quick summary of science and sort of where I think we are.
Because of the time, maybe we could have 2 choice questions and then on to the next speaker. At the end? Yeah. Okay, thank you very much. Okay.
Oh, sorry.
All right, I don't know if I can follow that up in any meaningful way that will be quite as enjoyable. So thank you for that. But in some ways, I'm going to start where Barth left off in terms of answering this question of whether the universe points to a designer. One of the things that we first have to acknowledge regarding the question of whether the universe points to designer and affiliated arguments about the cosmos and design is that there exist many ways of articulating design. So there are different sorts of design lexis and grammar. There's different sorts of design language that people provide when they talk about whether design exists in the universe. And of course, at the most basic level, essentially every theist would have to maintain that there's some level of design because they're theists. They believe in God, and they believe that the universe was created, and if the universe was created, that God designed it in some way. So at least at the very basic level, there's some acknowledgement from all theists, I would say, that the universe has to have some sort of design. But there's still different degrees regarding the type of arguments associated with design. And in my own research, I've looked at young Earth creationists and the contemporary intelligent design movement, and both of these different approaches to creationism and views of the world, they both approach the idea of design differently. So even young Earth creationists and intelligent design theorists, they approach questions and arguments of design differently. And in fact, due to the differences in such things as their approach to design, it's not uncommon to hear young Earth creationists and 9D theorists express hostility to one another. You know, one person isn't really expressing the right argument about design or not taking it to the right conclusions. And with that in mind, I guess I just want to indicate that from the outset that the question of whether the universe points to designer can rather unsurprisingly result in several types of answers. And specifically, my work has often been focused on examining the persuasive elements of intelligent design and young Earth creationist and also new atheist arguments, let's say for and against design. And I look at the persuasive elements rather than the cogency of the arguments themselves. So I look at whether they have, what the persuasive qualities are of arguments in addition to the cogency. And that leads me to my second point. Okay, so from the perspective of persuasion, I don't think it's necessarily unusual for people to find themselves experiencing a sort of intuition, a sort of feeling, to find themselves experiencing a kind of a sense of that when they look at the universe, when they look at nature, they get a sense of the order and the complexity and the elegance of it, of the natural world, and think that maybe this is the result of some design, some agency. How can the complexity of the natural world arise from chance and necessity without a designer? And in relation to that, I think in terms of persuasion, that there exists a kind of persuasive cognitive heuristic, which is associated with a widespread kind of intuitive appeal to arguments from design. And perhaps has been suggested by others that spotting design or detecting agency in the world around us is almost an instinctive thing that we have a propensity to do as humans. And in many ways, I think that Thomas Sowell was onto something when he stated this. He said, perhaps the simplest and most psychologically satisfying explanation of an observed phenomenon is that it happened that way because someone wanted it to happen that way. This applies not only to social phenomena, but to natural phenomena as well. Now, interestingly enough, leading atheists have even alluded to experiencing at least some measure of this, and some inclinations to describe things in nature in relation to purposeful design. And they've even noted that this inclination, this apparent complexity of design that we see as a problem that needs to be solved. So this is what Richard Dawkins calls the problem of complex design. And he says this in The Blind Watchmaker. The brain with which you are understanding my words is an area of some 10 million kiloneurons. Many of these billions of nerve cells have each more than 1,000 electric wires connecting them to other neurons. Moreover, at the molecular genetic level, every single one of the more than 1 trillion cells in the body contains about 1,000 times as much precisely coded digital information as my entire computer, which isn't necessarily as much because this computer was in the 80s. But the complexity of living organisms is matched by the elegant efficiency of their apparent design. If anyone doesn't agree that this amount of complex design cries out for an explanation, I give up. That's Richard Dawkins. And as a bit of an aside, while I have mentioned that, Dawkins and others kind of maintain that while there seems to be this persuasive element of this design intuition, Dawkins thinks the opposite is true of evolutionary theory. So he actually says it is almost as if the human brain were specifically designed to misunderstand Darwinism and to find it hard to believe. And he also says this: a third respect in which our brains seem predisposed to resist Darwinism stems from our great success as creative designers. Our world is dominated by feats of engineering and works of art. We are entirely accustomed to the idea that elegance is an indicator of premeditated, grafted design. And again, in the same book, he says of design, this is probably the most powerful reason for the belief held by the vast majority of people that have ever lived in some kind of supernatural deity. Now, interestingly enough, so this is Dawkins, Charles Darwin said this in his autobiography published in 1876. What's important about 1876 is it's quite some time after the publication of The Origin of Species in 1859. So another source of conviction in the existence of God connected with the reason and not with feelings impresses me as having much more weight. This follows from the extreme difficulty, or rather impossibility, of conceiving this immense and wondrous universe, including man, with this capacity of looking backwards and far into futurity as a result of blind chance or necessity. When thus reflecting, I feel compelled to look for a first cause having an intelligent mind in some degree analogous to that of man, and I deserve to be called a theist. Now, in the same autobiography, he also notes that he's experienced great fluctuating doubt regarding this conception himself. But in any case, he admits to feeling at least some sense of the magnitude of this possibility of design. And even contemporary biologists have complained that it is incredibly difficult for scientists themselves to describe aspects of physiology without using design-like language, without referencing the idea of purpose when describing the functions of some organ or cellular structure, for instance, seems very difficult. The heart is for this. The eye is for seeing. The eye does this. And so there's this element of design that creeps into language, even of biological scientists. Now, the prominent new atheist Sam Harris also conceded that this propensity that we seem to have to see design in nature and natural events may in fact be a biological disposition. So Sam Harris says this: similarly, several experiments suggest that children are predisposed to assume design and intention behind natural events, leaving many psychologists and anthropologists to believe that children, left entirely to their own devices, would invent some conception of God. And what Sam Harris is referring to when he's talking about the research are projects like those done by Paul Bloom and Dina Weisberg, who wrote an article that was published in Science in 2007. And they suggested that children tend to naturally attribute purpose and design to virtually everything, which is a propensity that they call promiscuous teleology. So they said, look, when we study all these kids, and kids from atheist households and non-atheist households, that was the interesting thing. So from all different households, all different backgrounds, these kids, very young children as well, from 3 years old onwards, the studies have been done, they seem to express this promiscuous teleology. So they seem to see agency and purpose everywhere. And Bloom and Weisberg explain this: when asked about the origin of animals and people, children spontaneously tend to provide and prefer creationist explanations. And when they say creationist, they specifically mean an explanation that involves a designer God. So there's a designer God behind it. Similar findings have also been reported in an article entitled "Are Children Intuitive Theists?" by Deborah Kellerman. And Kellerman concluded that identifying design and purpose in objects and predispositions to accepting design and theistic explanations seem to be psychologically present from an early age, from at least 3 years old onwards. So 3-year-olds already are clearly demonstrating this sort of tendency. And in light of this research, Bloom admitted, there is now a large body of research suggesting that humans are natural-born creationists. And now, these aren't people that are excited about this necessarily. We see non-random structure and design. We assume that it was created by an intelligent being. And Bloom goes on to say this, evolutionary biologist Richard Dawkins was right to complain then that it seems as if the human brain were specifically designed to misunderstand Darwinism. Somewhat related to this, the cognitive scientist Justin Brett, who used to be at the University of Oxford, has argued that the belief in gods seems to be a naturally occurring human phenomenon. Also looking at research with children, he too points out that people demonstrate what he refers to as promiscuous teleology. So people just seem to be looking for this teleology, this purpose in things around them. And what he calls an eagerness to detect design and purpose in the natural world. Psychologist Jesse Bering has argued that this trait is also not simply present in children, but also in adults. Even among staunchly committed anti-design evolutionists, the language of design and purpose appears unavoidable. The way our brains naturally develop compels us to wonder who or what is behind the evident design and purpose in nature. So there's this spectrum that exists, a range of answers that can be provided to the question of whether the universe points to a designer. And arguably, there seems to be a cognitively persuasive design heuristic that many of us possess. And this may actually stem from an apparently built-in psychological propensity to attribute design and agency to the world around us, whether you agree with ideas of design or not. So whether you agree that the universe points to a designer or not, there seems to be this propensity, even from biologists complaining about it through to psychologists talking about little children mentioning it. And what's important about this is how it can perhaps provide a different perspective about the question, does the universe display a designer? Because in one sense, that question is one of ontology. So about whether the actual nature of the universe displays design. So does the universe actually displays ontological design? But the other sense of this is that we also have to consider that regardless of the ontological nature of design, the universe will display design for us because of the way we are, the way that it seems that humans express the proclivity to see agency and design in the world around us. So whether ontologically the universe displays design or not, we are design-seeking creatures. We have this psychology of identifying agency in the world around us. Now, moving on, how is the persuasive design heuristic and this psychological propensity to see design being, systematically articulated when we look at the universe? Well, broadly speaking, arguments from design have historically begun with some empirical observable feature of nature, and then in some way concluded by inference that a designer exists. And arguments from design have often been split into two primary categories. Arguments from analogy and inferences to the best explanation. Now, the first one, arguments from analogy, essentially draws parallels between human artifacts and what can be found in the natural world. So it then states that because one, so the human artifact, the first one, the created object, was designed, we can use a sort of analogical logic to conclude that the natural object was also designed. So if one was designed, we can draw some sort of analogy between the natural object and say that that was designed. So, one, human artifacts are intelligently designed. Two, living organisms and their parts resemble or are analogous to human artifacts. So maybe they do the same sort of thing. They're both complex in similar ways. Maybe their parts work together to perform some similar function. Three, similar effects often have like causes. So if you see one thing and you see another thing, they're similar, that something similar may have caused both of those similar objects. And therefore, living organisms and their parts are probably intelligent designed as well. In a New York Times article, incidentally, Daniel Dennett. This article was called Show Me the Science. The new atheist, Daniel Dennett, referred to a simplistic questionnaire produced by anti-evolutionists to explain, in his mind, the ridiculousness of such claims. So the questionnaire stated the following. Do you know of any building that didn't have a builder? Yes, no. Do you know of any painting that didn't have a painter? Yes, no. Do you know of any car that didn't have a maker? Yes or no? If you answered yes to any of the above, give details. Daniel Dennett then states, take that, you Darwinists. But he also goes on to identify the sort of natural intuition that is incorporated in even these sorts of basic design by analogy arguments. He says this, the presumed embarrassment of the test taker when faced with this task perfectly expresses the incredulity many people feel when they confront Darwin's great idea. It seems obvious, doesn't it, that there couldn't be any designs without a designer, and any such creations without a creator. And with reference to arguments from analogy, David Hume, in the 18th century, of course, famously countered these sort of design arguments by analogy. And he said, first of all, look, this type of analogy isn't a very good one. He said, just because it's hard to make an analogy between something that's designed by humans and natural objects. So that was his, he said that basically. He said that, look, the world and its contents, such as organisms, are not necessarily analogous to human artifacts. And he also contended that even if such analogies can be made, so even if you can make some sort of analogy between a human-built artifact and a natural occurring object or an organism, he said, that doesn't necessarily point to a single designer or the kind of God envisaged by people employing these kinds of design arguments. Now, in relation to this, these kind of arguments from design, there also emerged a greater complexity with these sorts of arguments, which draw away from making direct analogy to human artifacts, and instead we kind of see design by analogy claims that just say that natural objects or the cosmos itself merely reflect design-like properties. They're not necessarily analogous specifically with certain objects. They can just say, well, we know that certain objects have design-like properties, and maybe the same is true for nature. Now, the second category of argument is called the inferences to the best explanation. And they're arguably much more prominent today, as they are often associated with the contemporary intelligent design movement. But though in my research with young earth creationism, it's still not unusual to find arguments from analogy. Now, with inferences to the best explanation, certain features of the universe are treated as data, or certain aspects of the universe are used to derive some sort of data, and then various hypotheses are offered to explain the data. Where usually one hypothesis is that intelligent design is the best explanation for what is observed, and then another of the hypotheses is that non-intelligent causes provide the best account. And then from a comparison of the two hypotheses, an inference is made regarding whether the data expresses design or not. So most often, the two types of design arguments associated with inferences to the best explanation are affiliated with fine-tuning arguments and biological design arguments, so biological complexity arguments. So let's say the apparent data seems to suggest that there are limited parameters in physics that would allow life as we know it to exist in the universe. I don't know if you heard this ever, like in the last 20 minutes. But let's just say that's the argument, and that there are these very fine-tuned values in the universe that have to be fine-tuned to allow life to exist down to the subatomic level. And even if an extraordinary parameters in the laws of physics were to have been different, then life would be impossible anywhere in our known universe. Or perhaps data reveals that there are incredible complexities to biological life. So let's say there's incredibly complex intracellular natural mechanisms. Now, we can draw two hypotheses for each of these sort of statements, these sorts of claims. So one is that the fine-tuning of the universe or the complexities of natural mechanisms are due to intelligent design. So that's the first hypothesis. The second one is that the fine-tuning of the universe or the complexities of natural phenomena are due to non-intelligent factors such as chance and necessity. And from this, the arguments tend to follow this sort of course. So we'd expect fine-tuning for life if the first hypothesis is true, so that there's an intelligent designer. We wouldn't expect much fine-tuning if the second hypothesis is true. Well, we wouldn't expect anything because we wouldn't be here. But if we expect that the data is more likely to exist in the first case than it would be in the second case, then the first hypothesis is more probable. So therefore, the inference leads us to believe that the first hypothesis is more probable than the second, and the data we observe is best explained by intelligent design. Does that make sense? Yeah. Now, in relation to these sorts of conclusions, there are frequently appeals to likelihood principles or mathematical probabilities. So what's the probability of something like this happening? And these are employed to demonstrate that the first hypothesis, the design hypothesis, is more plausible. Arguments from design, of course, have garnered quite a lot of attention in popular discourse with the ascendancy, as I said, of the modern intelligent design movement, which they're often referred to as kind of the new Darwin skeptics. Now, without expanding more on the intelligent design, the new intelligent design movement, essentially at the heart of intelligent design, is a fundamental inference design premise that there exist some complex biological adaptations, for instance, especially at the intracellular level, which could not have resulted from natural selection or any entirely materialistic process. So they could not have arisen from merely chance or necessity. And the big, two sorts of arguments, or the names of the arguments affiliated with this, are irreducible complexity and specified complexity, and I won't get into those. But associated with these sort of design arguments, with the ID movement and the spectrum of views on design, and one thing that often distinguishes the contemporary intelligent design movement from other design arguments on the spectrum of various responses to design. So in terms of different languages of talking about design, one thing that differentiates the contemporary intelligent design movement from other previous arguments or other arguments that are existing is that it's claimed that one can essentially infer the handiwork of the designer through scientific tools and ways of thinking. So not only does the universe point to a designer, but the design can be detected through scientific means and principles and premises. And the contemporary prominence of the ID movement and ID contentions have drawn quite a bit of criticism from various corners, including and perhaps especially modern atheists, sometimes called the new atheists. And not all new atheists like being called new atheists, but I'm just going to refer to it because it's easier. Now, wrapped up in the new atheist reactions to intelligent design are criticisms of all arguments designed. So, I talked about that there's a spectrum of design arguments. Essentially wrapped up in new atheist arguments against the intelligent design movement are simply arguments against all design contentions. So what are the prominent criticisms leveled at considerations of design in the universe, especially in relation to the intelligent design arguments that I mentioned? So here are some of the most prominent new atheist arguments that are expressed in contemporary mass media, which you'll see also take their cue from David Hume. So one of the first one is that these are ignorance and or gaps of knowledge. So the assertion is that design arguments are weak because they rely on the existence of some natural facts which science has, as of yet, failed to explain. Science can explain this or it can explain that in terms of materialistic explanations, so let's say involving just chance and necessity, and therefore we can find a place for God's creative act, or that's where intelligent design people put God's creative act. That's the problem with this strategy, it is pointed out, is that in the long run, scientists do eventually find ways of filling some gaps. So gaps are always getting smaller. Even if new gaps crop up, there's a chance that that gap will eventually be filled in. And when they do, God can no longer be regarded as the best explanation for those phenomena. So arguments from ignorance are described as being weak, and dangerously so in their short-sightedness in view of their constant threat of obsolescence. So when you base an argument on ignorance, perhaps that area of ignorance will eventually be explained. So where do you find God? Poor design. So with this argument, it's claimed that if an omnipotent and omniscient God had designed our world, then we would expect it to be a relatively flawless creation. So, and therefore, any apparent flaws in design would suggest the designer seems to lack knowledge or power or other qualities often associated with, let's say, Judeo-Christian God. So accordingly, contemporary atheists frequently assert that there are features of the natural world that if they were designed, they're somewhat design failures. Right? So if these things were actually designed, then they seem to be pretty crap design. So Richard Dawkins argues that if natural objects like the eye, for instance, in some of his work was designed, then we can only laugh at the absurd design exhibited. So essentially, some of this stuff actually seems to mock the idea that there's a creator. So along with inadequacies of the human eye, there's people. Some of these arguments point to a potentially dangerous appendix. Seems to be not really very useful. Weaknesses in the human spine and the pain of childbirth are used to support such arguments. So they say, look, all these things don't really show particularly great design. The knee, I've heard, joints. What kind of designer does design reveal? So even if we were to accept that the evidence points to a designer, again, and you can see Hume's influence here, we are still very unclear what sort of designer that agent is. So maybe at the best, design reveals many gods. So maybe there's a lot of designers working together, like, as Hume said, a ship. So we know that a ship is designed. When we look at it, and he was talking about wooden sail ships, okay? So we see these great wooden ships. We know that they're designed. They're clearly designed. But you can have an inept apprentice making part of the ship, and then you can have an expert making the other part of the ship. So it's still designed. It still works, but there's a couple guys working on it, and one of them's inept. So just because something's designed doesn't necessarily tell us exactly a great thing about the designer. So just because something points to a design doesn't necessarily mean it points to a perfect designer. So maybe at best design reveals many gods or some god that's limited in power and knowledge, hence my bad back. And even if sin is used, so even if the fall is used to explain the cause of bad design, or what is interpreted so, as some Christians might argue, that God still initially designed the prerequisites of the cosmos such that the fall would have to been a possibility, which seems like a bad design. So as a consequence, God is interpreted as not being maybe completely good, because the design doesn't necessarily point to, a flawless, omniscient God, apparently. Complexity regress. So with this argument, it is claimed that, and this is another one that Richard Dawkins makes, because according to design arguments, complexity implies design. So if we seek certain levels of complexity, specified complexity, for instance, in the intelligent design movement context, that implies design. So if we have complexity, it equals design, and if there's design, there must be a designer. So the argument then is made is, well, if a designer made all this complexity, then is that designer not also complex? And if the same logic would assume that if the designer is complex, then that designer must have a designer. And there's an infinite regress. And the designer must have a designer, and on to infinity, which is absurd. Supernatural natural replacement. This is an argument based on historical premises. So it is stated that over the course of history, supernatural explanations have always been replaced with natural ones. So when we have had supernatural explanations in cultures, eventually those supernatural explanations are replaced with natural explanations. So it's very unlikely that natural phenomena, because of this historical reality, it's very unlikely that natural phenomena will suddenly be found to have supernatural causes, as is claimed by members of the intelligent design movement. And then there's the last one, which is counter probabilities. So these are essentially answers to the statistical sorts of mathematics and probabilities that are used in design arguments to back up design arguments. So one of this is pointing out probability measurement. So where some arguments for design rely upon probabilities or the improbabilities, so probabilities or improbabilities of something occurring through only chance and necessity, it is pointed out that often the measurement of probabilities is suspect. So probabilities is especially related to things occurring in the past are difficult to test or validate. So how do we test certain probabilities? How do we test the probability that a certain cellular structure could never come into being through chance and necessity? Probability assumptions. So also there are problems with the assumptions used to determine probabilities in a biological system. So there are different ways in which this is articulated. So Dawkins points out that there are differences, for instance, probabilities existing in ideas of cumulative selection. So this is the idea that in which each biological change, let's say even very slight, is used as the basis for the next round of selection. So this is cumulative change. He said the probability of something coming out from cumulative changes is much different than single-step selection, where we try to find the probability of something that's already existent and very complex coming out very quickly over one step. So it's extremely unlikely that single-step selection will generate incredibly adapted complex structures, but in terms of probabilities, the mathematics of likelihood are changed when we consider cumulative selection. And then there's scales and probabilities. So with this, in terms of answering to design, intelligent design use of probabilities, with this idea, improbabilities is answered with sheer numbers. So massive time scales. So are the complexities of life so improbable, it is asked, when considered with the estimates of when life appeared on the Earth about 3.5 billion years ago and adding energy? Right? So the idea is that it seems very improbable that there might be a complex life form existing, but what happens if we just throw a lot of time at it? Then maybe those probabilities don't seem quite so vast. Now, these arguments are not limited to the new atheists. You can find many other theists making similar claims against intelligent design theory or other design premises. For instance, it's not uncommon to hear members of BioLogos, for instance, a Christian pro-evolutionist organization, make other complaints about design and maybe claim that by allowing supernatural explanations to count as science, that undercuts the very purpose of science. Which is to explain the workings of nature without recourse to religious language or religious explanation. So they ask whether scientific methodology can actually detect or measure the handiwork of a designing God, because that's not necessarily what scientific methodology is meant to do. So while many people argue that God's existence is actually a scientific claim, that could be tested, like a chemical reaction can be tested. The rebuttal is that science studies the natural world, not the supernatural world. So no amount of scientific testing or theorizing can prove the handiwork of God or can detect the handiwork of God. So what do we make of all this? Okay, first again, while I've focused on some very specific examples of arguments from design, there actually exists quite a large spectrum of design language and views on design. And I think there also seems to be a very good case for saying that design thinking, detecting design in the cosmos, whether you agree with the ontological idea that design exists in the universe or not, it has intuitive persuasive qualities. And this persuasive heuristic of design is potentially aided by our inherent psychological propensities for detecting design, apparent from even a very young age. And in that respect, I think it's very hard to avoid the idea of design in nature, whether it's perceived to be there or not, simply because we seem to have design detecting inclinations. So when considering the new atheist criticisms of design, you may also have difficulty or differing reactions to them. So you might consider them persuasive, at least somewhat helpful when thinking about design arguments, or you just might not find them very compelling. But in any case, I think that they do reveal potential dangers in maintaining certain design arguments, and the fact that there can be problems with types of suggestions of design. So what if faith, for instance, becomes based, at least to some degree, upon aspects of scientific ignorance? For instance, what then happens to that faith when light is shed on potential mechanisms that might account for that previously unknown or considered improbable thing? So in relation to that, with all this in mind, I'll end with what I hope is a somewhat provocative statement about design arguments that I'll leave you with to reflect upon. Okay. So when considering the question of whether the universe points to a designer, at the very least, we seem to have trouble resisting seeing design. And the potential dangers of design may lie in the differing degrees of design being advocated. Thank you.
I am on. Thank you very much. A pleasure to be here. I am the token theologian, which means I know nothing about science. That's part of the deal. I'm the son of a scientist, but the reality is I never understood a thing he did. So, but I was glad to hear about Dawkins, who seems to think that people are designed to misunderstand Darwin. That explains a lot, because I think most people clearly have their brains designed to misunderstand me. So here we go. We'll test that one out. Now, I've been asked to talk about natural theology, and I'm going to do that in two parts. First, talk a little bit about some of the history of how theologians have approached it in a very broad way, which will pick up a number of things that Tom just covered. And then I'm going to, in the second part, offer my own view for what that's worth. Now, the phrase itself, natural theology, very contentious one, especially in the last century. And it admits of a range of meanings, clearly. At its most basic, though, natural theology, the phrase itself, refers to the act of discerning truths about God from the natural world. Now, it's not just about design, you see. That's what everybody focuses on today. But it could be any number of truths about God, perhaps. So that world from which one might discern truths about God could be a human-centered world. It could involve human feelings or attitudes or customs. Hence, the whole area of what people sometimes call natural law. Or what we discern about God could come from the natural world that includes non-human elements of reality, animals, rocks, physical processes, cosmological phenomena and principles. And in this case, we would be dealing with what we call natural science. So the question then for natural theology is, what can we know about God from knowing something about this range of elements, human elements, non-human elements of reality? Can we know anything about God from knowing something about these things? And as I said, while the issue of divine design of the universe and its elements has been a very prominent one in discussion over the last, say, 200 years, in fact, natural theology has traditionally included far more than this single bit, however important, of information. So, for instance, there is the famous 17th century astronomer Johannes Kepler, who, as some of you may know, attempted to outline the very complex calculation of harmonic proportions associated with the orbits of the planets, the actual sounds of the universe. There you are. These are the sounds that the planets make according to his calculation of the various ratios and so on of their movement as he had or was able to figure it out. And yet, by including the Earth in what was a very Platonic scheme, the Earth, he calculated, actually moved, according to all of his various things, in a minor third. And so he said that it's clear that, well, where did that go? There we go. That lament itself. Now I'm supposed to hit this, is that right? Lament itself is a part of the universe itself, and hence a sign of Christ's redemptive work. Now, it's interesting, in this big book he wrote about the harmonies of the universe, he refers to Orlando Lasso. He's not thinking about some weird computer generated. Obviously, he didn't have that at the time. But Orlando Lasso is writing motets about, in this case, this was the one he actually cited, "Your wrath has swept over me," from Psalm 87, that begins with a minor third. He said, Lasso was actually reporting musically on the depth of God's redemptive love, given the failures of sin in the world. Well, does this make any sense whatsoever? Now, let's move to the major question theologically. There are no dogmas in any church associated with the question of natural theology. Some people think it's a Roman Catholic idea, but it's not. For instance, the Belgic Confession, one of the great 16th century Reformed confessions, begins by saying, we know God by two means. First, by creation. I better turn this off. It's more interesting than what I'm saying. I'm not sure I can do that, though. All right, let's go back to the last one. Okay. Oh, no, then we're going to have to listen. We're going to have to listen to the sounds of the universe. Let's go over here. All right. So, says the Belgic Confession, we know God by two things. First, by creation. And by the creation, preservation, and government of the universe, since the universe is before our eyes like a beautiful book in which all creatures, great and small, are as letters to make us ponder the invisible things of God. And then, of course, there's the Bible. But it begins, the Belgic Confession, with this claim about the book of nature. So no dogma other than possibly we might know something about God from the universe. If there is a major dogma undergirding the notion of natural theology, it is simply that created matter, and we can determine in our day what that includes, created matter is good. And that, of course, goes all the way back to the early church. As the creed said, God is the creator of all things, visible and invisible. But beyond that, it is unclear what to make of this fact in terms of its divinely revelatory capacity. Now, of course, there is the Bible. What does the Bible say about this? There's the famous text from Romans 1, where Paul writes, because that which may be known of God is manifest to human beings, or plain to them, because God has showed it unto them. For the invisible things of God, of Him, from the creation of the world are clearly seen, being understood by the things that are made, even His eternal power and Godhood, and hence they are without excuse. That's one, and that's probably the most famous text that people refer to claim that there is a biblical notion of natural theology out there. The problem, of course, is that Paul goes on to say that people got all messed up on that. Now, on the other side, there's something like Job, who stands in awe of God and His works. But he stands in awe not as a means of gaining understanding, but as, in fact, a prod to silence. This is a quote from Job 26. God described a circle upon the face of the waters at the boundary between light and darkness. Lo, these are but the outskirts of His ways, and how small a whisper do we hear of Him. We hear something, but not much that we can really grasp. Later, Job, as we will hear, will simply, quote, lay his hand on his mouth and proceed no further. Voltaire, much later in the 18th century, had a certain schizophrenia about this, which I think still is in place for many Christians who think about natural theology. On the one hand, Voltaire, who was a theist, it appears, by and large, adamantly defended human embryos as being directly created by God. And he mocked completely explicit atheists like the Baron d'Holbach, who claimed that things arose, this was long before Darwin, if you will, naturalistically. But at the same time, Voltaire also had looked into the whirlwind of the great earthquake in Lisbon in 1755, which, as you know, the earthquake and the tsunami after it killed tens of thousands of Lisbonites, while they were even yet at Mass Sunday morning. And it created a terrible, terrible sense of crisis in terms of religious conscience all across Europe at the time. And Voltaire wrote his famous poem about the Lisbon earthquake a year later. And after confessing that while he would, quote, never raise himself against Providence, he then declared, Que faut-il aux mortels? Mortel, il faut souffrir, se soumettre en silence, adorer et mourir. That is, what must we do, O mortal men? There is nothing to do but to suffer, submit in silence, adore, and die. If God creates, that is, God also destroys. And therefore, what we call natural law of one kind or another thus becomes rationally veiled. In the poet Edward Young's poetic version of the book of Job, he writes, Deep are those shades, but shades still deeper hide my counsels from the ken of human pride. Hence, the tradition of natural theology, it has to be said, doesn't have a whole lot of coherence within the Christian experience over time. There is a cacophony of voices that have tried to address it from these differing perspectives of harmony versus disaster. And you have only to look at the range of the famous Gifford lectures that are devoted to this theme to realize that it is all over the place when people try to make sense of it. The heyday of natural theology, of course, was the 17th century, when the actual study of the natural world was simply assumed to render a witness to God's own being as that thing which sustained the integrity of human scientific discovery. And so something like the front piece of a Francis Bacon volume of natural history, here you see the picture of the light of God as a light that is bound to human reasoning, but also engaged, as it were, through attention upon the created world. That is to say, God is uncovered insofar as human reason is deployed upon created matter. That was the assumption. As we actually think rationally about the world, we see God, if you will, automatically, because that is what rational attention is all about. Now, the coincidence of this kind of divine reason with creation was celebrated most fully in the attempts of that era, the 17th and early 18th century, to trace actual scriptural reality as something that would be congruent with rational scientific form. Thus, for instance, at the time, very famous writer and artist Christoph Weigel, who had the notion that the Bible itself depicts explicitly, if not entirely, every element that science can articulate. So he wrote, in 1695, published the Biblia Ectipa, which was a pictorial Bible, the whole story of the Bible, only in pictures. And in the course of this, he carefully gleaned scientific images from scientific volumes for his representations of creation in their scriptural form. The two are the same, you see. You can look at what Genesis is saying by looking at what the astronomers have described. You can look at what creation was about by looking at what natural historians and biologists were able to describe. And this comes to the head in a very famous work of Johann Jakob Schweitzer in 1731, his book known as Physica Sacra, Holy Physics. The Bible is, Schweitzer asserted, a spiritual textbook of natural form. And so in the course of his book, each depiction of the natural world and his explanation of natural science is bound to a scriptural text that, as it were, opens up the experimental cabinet. So here you've got the picture of the heart, which is taken from anatomy, and underneath this got cut off from Psalm 33. You have actually a verse about God creating the human heart, and so on. And this goes on with the ear and with absolutely everything. The whole book is a coordination of these naturally physical depictions with scriptural verses. Of course, this is the kind of thing that William Paley made famous several decades later in his Natural Theology, 1802, which was so mocked later by many others, but it was a standard textbook in Oxford, I think, for many decades. He would depict in his illustrators everywhere, again, the human heart and so on. And some of the arguments that are far more sophisticated today, of course, were already there. The complexity argument and so on is all presented in this sort of way. Now, God is not very close in Paley. The scripture verses are not represented. They've disappeared. But God is still explicitly hovering about as, of course, as we heard, the grand designer of everything. And, of course, it was this designer that Hume, as we heard just a moment ago, so famously, and still, in a way that is applicable for many philosophers, famously mocked. But understand that the mockery about this notion, these pictures of the natural world as being directly related to scriptural revolution, these ideas were not mocked only from the side of atheistical skepticism. There are obvious problems with the simple two books notion from within Christian theology itself. For instance, what of, as we heard a moment ago, original sin? Are our cognitive capacities sufficient for apprehending God, given the assertion of sinfulness as something intrinsic to our existence? And we might also wonder, leaving even sin aside, whether the infinite distance in kind, if you will, between God and a human creature, any creature, but a human creature, at infinite distance ontologically between the two, must render any understanding of God on our part as wishful thinking through the mechanisms of our created capacities. Many theologians began to ask these questions. Are our cognitive abilities capable of apprehending God simply given our biologically ordered existences? Now you see these questions gaining traction just as natural theology reaches its zenith in the 17th century. Yes, many insisted we learn what is good and true by copying nature. That's the positive side. So you have these whole ideas that nature, this is about allegory of nature and painting. And if you can read the Latin, the whole idea, it says, is that painting follows the benevolent lines of nature. We can copy what nature represents, and we can have art simply by copying it. Of course, you had other allegory here of Apelles, who is in the Greek mythology, the great originator of painter, having, hopefully a modest but romantic affair with nature there, because art and nature are exactly one. Okay, that's the notion that you can look at the world and around you and see the absolute beauty and truth and goodness that's intrinsic to it, which of course leads us to God. But then the question at the same time began to arise, but can we rightly perceive the truth of nature in this way? And it rose, of course, as people began wondering about the horrors of, if you will, human apprehension of nature. Here we have a famous, it was famous at the time, 18th century engraving by Charles Gaucher, allegory of nature, where what we're seeing is that human beings are corrupting her. Here is nature, and she is sucking at her breast are children of two races, Caucasian and African. And yet behind what we see are European Caucasians oppressing, beating, and causing the suffering of Africans, human beings. So the contrast, of course, is between what nature is and what human beings actually perceive in their actions with respect to nature. More fundamentally, what if, in fact, nature itself is turbulent? Forget about the moral problems of our perception, but what if nature itself is viewed as something twisted, violent, and fallen? This actually is an early 17th century painting by a remarkable Flemish artist, Louis Finson. It's an allegory of the four elements, as say of water, fire, and so on and so forth. And they are struggling over Earth, who is this elderly, fallen, wrinkled woman. And they are pulling her apart. Nature itself is destroying that which we consider our very home and our very place of nurture. What we call nature is, after all, as some theologians began to ponder, nothing finally but a vain and empty metaphysical shell in whose vacuity we as creatures share. Of course, this is part of the grand tradition of the vanitas, or the nature morte, the dead nature paintings, which are about human vanity. Flowers in their beauty, of course, dry out and die, and the petals fall, and the beautiful pearls and so on disappear. And of course, there in the middle is the skull of human mortality. Can any of this actually be, if you will, a lens upon the nature of God? And if so, how? So the argument heated up, and it has enveloped Catholic and Protestants in its wake. So here I go to the second part and give you my own view about this. And it's one, I hope, that can bridge some of these divergent views of natural theology that Christians themselves had by normalizing, if you will, the tension at work between natural revelation and the natural perversion and perversity, if you will, and obscurity of our life in the face of such revelation. Those who have studied with me, perhaps, will not be surprised to hear that one of my heroes is Michel de Montaigne, who was a skeptical humanist Catholic of the 16th century. He was enormously disoriented by the religious wars of his era and baffled as well as fascinated by the news of human diversity, now located in places like the Americas and China, which had only recently been encountered by Europeans. Montaigne provides one of the most famous refutations of simple natural theology in the literature, at least the natural theology as it was practiced at his time. He enumerates with amazingly literate detail the confusions, deformations, ignorance, and blindness of human knowledge and its claims to grasp the world and its bewildering mysteries, let alone to grasp God. The human senses themselves, foundation for empirical science, Montaigne finds as pitiful in their incapacity and deafness. And so he seems, as a result, to reject natural theology altogether in favor of perhaps a purely fideistic approach to God. We can't reach God by looking at the world, but perhaps we can simply have faith and make the leap of faith to know him. Yet Montaigne is, as all his readers know, a consummate describer, one of the best in the business. This is actually a picture from a book that we know he read very carefully and talked about in one of his essays, the account of Jean Léry in Brazil in the 16th century. He read many of these things and all kinds of things and wrote all about them: people, cultures, landscapes, small animals, human physiology, and so on. Indeed, Montaigne insists that such description, simply by doing it, in all of its breadth, must tell you something fundamentally true. So true, in fact, that we can also claim something fundamental as a result of our simple examination of the world. On the one hand, his critique of human epistemic integrity marks a sort of necessary clearing operation for the receipt of grace or revelation. But insofar as it does just this, then description of the world eventually constitutes our humility which itself represents God at work in us. Descriptive effort, that is, bound to its own incapacity, forces us to admit to our ignorance and puzzlement in the face of the world. And that is itself, Montaigne claimed, a kind of articulated truth regarding who we are in relation to God and God in relation to us. Well, what kind of natural theology might come from this? I'll give you an example. The great Anglican 17th century theologian Thomas Burnet wrote a bestseller at the end of the 17th century, which was entitled, in the English translation, A Sacred Theory of the Earth. Burnet sought to provide a theory as to the Earth's origin and its transformation through the Great Flood, obviously spoken about in the Bible. And then he moves on to a third volume, its dissolution, the world's dissolution at the end of time, and finally, its renewal in paradise. But what was striking to all readers of his book was his careful but vivid argument that the world was originally created by God in a perfect form. It was smooth and even and absolutely wondrously perfected globe. What happened, of course, was sin. And sin brought about the flood, which in Burnet's argument then wreaked havoc on the earth and turned it into its present form of topsy-turvy disorder, of continents, coastlines, mountains, and all the rest. This is from his book, in which he shows how the flood and the waters actually broke apart the earth, creating all these jagged coastlines and islands and all these sorts of things like that. And here I quote from him. We must, therefore, be impartial where the truth requires it and describe the earth as it really is in itself. And though it be handsome and regular enough to the eye in certain parts of it, single tracts, single regions, yet if we consider the whole surface of the earth or the whole exterior region, 'tis as a broken and confused heap of bodies, placed in no order to one another, nor with any correspondency or regularity of parts. And such a body as the moon even appears to us when 'tis looked upon through a good glass, rude and rugged. They are both, in my judgment, the image or picture of a great ruin, and have the true aspect of a world lying in its rubbish. This became a very famous text, often quoted. So he says, too, about the mountains. If one could see, I say, all the earth at one view, how the mountains lie in broken heaps. The sea hath overwhelmed one half of them, and what remains are but the smaller parts of, again, his famous phrase, of a ruin. In what confusion do they lie? They have neither form nor beauty nor shape nor order. Then how barren, how desolate, how naked are they? How they stand neglected by nature. So sin, through sin, then the flood came and ruined the perfected shape of the earth. And Burnet goes on and argues the whole solar system, it seems. Light changes because the earth changed and moved on its axis. The atmosphere changes. Health of all the creatures goes downhill. Having kids and babies and sex is all messed up. The earth becomes a place of change, dissolution, waxing and waning, ultimate entropies. All right, sounds pretty awful. Yet Burnet goes on and then says this mysteriously, and I quote him, "The greatest objects of nature are, methinks, the most pleasing to behold. And next to the great concave of the heavens and those boundless regions where the stars inhabit, there is nothing that I look upon with more pleasure than the wide sea and the mountains of the earth," which he has just finished telling us are nothing but disorder and disfigurement. And it would be a prophetic claim. That is, that in its twisted form, the earth is the most thrilling wonder to behold of anything imaginable. The literary critic Marjorie Nicholson in 1959 came out with a very influential argument, followed now by many others, and that is that Thomas Burnet's vision in this book of the massive yet wonderfully disfigured world caught the imagination of the next succeeding generations, finally giving rise in an almost direct genealogy to the romantic vision of nature's awesome sublimity. Not in spite of her ragged brokenness, but just because of it. And that is, people like Ruskin in the 19th century and others before him were caught up in the sheer beauty of nature's fallenness. The two go together. And the point is simple. Original sin need not cloud a sense of God at the heart of natural life. But why is the question? There's something about the contemplation of natural being itself, that is, of something existent in its existence, in its bare contingency, in its passing away as mortal, if you will, which is what existence in fact is. There's something in this that generates astonishment of the deepest kind. And in fact, phenomenologists in our own era have actually engaged this question, although also much earlier. People like Augustine to Descartes, but in our own day, Michel Henry, Jean-Luc Marion. To think about that which is, barely to think about it, is to walk along the infinitesimally thin ridge of self-consciousness that rides above the edge of that abyss of perceptual loss or madness. It's the threshold of description itself. To walk there on the edge of existence is to describe simply what is. And that is to say something mysterious about who we are. Now, some scientists move in this direction. Albert Einstein arguably did. Certainly many early modern scientists did. But often this sense of God as the condition for being is hard to translate to those outside the field, except if you provide imagery in some way. If you can see it in astronomy, biology. That is, to see is to believe, and to believe something deep, troubling, beautiful, yet precisely also inexplicable. But we're drawn into just this place. I'll just end with an example of famous 20th century photographer Roman Vishniak. And I only do this because I saw an exhibit of his work recently. He was a Russian, then German, then French, and finally American professional photographer, and commissioned in the 1930s by the American Jewish Joint Distribution Committee to record the lives of Eastern European Jews. This is the 1930s. And they turned out, these pictures he took, to be one of the last set of images we have of people in that part of the world before these communities were utterly destroyed. There are many of them. Many of these images are famous. And he returned as well after the war to where he lived as a teenager in Berlin. Now, the question is there something beautiful in these images? They are of people, many of them poor, most of them most likely destroyed a few years later, like his home in Berlin, as he pictures it, as I said. But Vishniak was also back in America later a pioneer in photomicroscopy. That is to say, one of the first to put on paper images of the microscopic world beyond our normal vision. He was one of the pioneers of this. This is of a root of some vegetable of some kind. And my point is simply this. The two sides, Eastern European Jewry in its disappearance and the amazing forms of plant roots, were driven by the same descriptive press that he lived under in his vocation and that he saw as possessing the same revelatory character. And what is this character? Basically, it is made up of two attitudes through which creation or nature, I would argue, is ordered by God, and that must always be held together. That is to say, praise and groaning. The created order praises God. In the psalmist's words especially, praise him, sun and moon. Praise him, all you stars of light, trees, fields, the earth, the deep. In Augustine's words, all of creation says to God, you have made me. Yet at the same time, as Paul writes, we know that the whole creation groaneth and travaileth in pain until now. So each of these and together, praise and groaning, constitute the limits as well as the purpose both of natural theology. That's what I would say. For each of these is bound to God, both bound in the fashion of creaturely existence. It is, as Montaigne in his own way insisted, this element that orients natural theology to creaturely description, almost purely. We are, yet we are as creatures of God. And thus, to describe the world as finely as possible is to uncover our God-givenness, whose quality is enunciated in praise and groaning. Creation cannot tell us anything about how to act outside of these two basic and purely elicited responses. Describing creation cannot solve problems. It cannot engage moral reasoning. It cannot uncover the purposes of history. It cannot divulge specific truths about human purpose. But it can drive us to God, if only because to be a creature is to be so driven in and of itself, intrinsically, purely by the fact that we exist. And to this degree, the natural sciences themselves are also purely descriptive, and it's important to see them as such and therefore to see their role in natural theology. Evolution, quantum physics, one can argue to what degree they represent facts or theories. That is to say, to describe is to put into words or figures something that exists otherwise. It's to theorize. And the sciences are attempting in their own way to represent the way creation is, or how it moves, or how it looks, insofar as this is their purpose and their touchstone. But that is what they are, and to this degree they are as devotional as the paintings of the 17th century painters, and as devotional as the harmonies of Kepler. Here is Hans Holbein's to end his Dead Christ of 51. It is a masterpiece of morbid anatomical description. Yet it is also just because of that, standing at the trembling threshold of God's love in creating human mortal life, and yet also coming to it, it is at the trembling threshold of God himself. In the tradition, both Jewish and then Christian, there was a good deal of discussion about the meaning of Exodus 33:23, where God passes by Moses and allows him to see, but only this, see his divine backsides, or his posteriora in Latin. What did that mean? God's backsides. Maimonides argued mysteriously, others did the same, but I think this backside of God is what natural theology engages, coming up at God via that which God is not, yet has allowed to be in its dangling uncertainty. And let me end with a quote from G.K. Chesterton's novel, The Man Who Was Thursday. The main character famously divulges this bit of wisdom after surviving a confusing and frightening series of adventures. "Listen to me," cried Syme. This is the character with extraordinary emphasis. "Listen to me. Shall I tell you the secret of the whole world? It is that we have only known the back of the world. We see everything from behind, and it looks brutal. That is not a tree we see, but the back of a tree we see. That is not a cloud, but the back of a cloud. Cannot you see that everything is stooping and hiding a face? If we could only get round in front." The back, though, is not only groaning and brutal, it is also, for there being a back at all, a back to see it all, quite marvelous. And that is the fundamental, I believe, basis of natural theology. Thank you.
Well, that was wonderful. Have arguments for design and counter-arguments, the limits of arguing design in the way it's been explained. And finally, a tour de force on natural theology and what we can learn from the heavens that declare the glory of God but on the downside, the agony and seeing things from behind. So I can see definitely now a directionality, which I couldn't at the beginning. So let's open it up to questions. I was going to suggest that we get up, but I'm afraid that some of you might leave and miss the rest of the feast.
I'll take the
So
question around.
let's have some, please indicate who you're directing the question to.
If you could pass the mic to the person, that'd be great.
All right. Good evening. This is directed towards the professor. I was just wondering what's your opinion on the theory of the boundless universe, the theory of the boundless universe, and if the universe is boundless, and infinite number of galaxies are there.
Okay.
What's true in one galaxy or one universe be contradictory in others. So would we ever find the truth? And I'll leave it at that. Yeah. Thank you.
Okay, you're asking about the infinite numbers of universes, or the idea that our universe itself is
The theory of boundless universe.
the idea that our universe is infinitely large.
Yes.
Yeah.
So it's infinite, so it's boundless.
Yeah. So that sort of depends on the geometry of the universe. If the universe is slightly closed, then it will be finite, kind of like the surface of a sphere is finite. If the universe is slightly open or exactly flat, then it will be infinitely large. We know that it's within 1% of flat, so it might be infinitely large and it might be finite, and there's no way we can ever know. So at that point, then my opinion is as good as anybody else's. So, so now you want to know my opinion? I kind of like, depends on the day. Today I'll like a toroidal universe, but I won't tell you what that means.
Thank you, gentlemen. Thoroughly enjoyed the evening. I have two questions. I hope that's okay. The first is for Dr. Radner, and I'm wondering, and you guys might want to keep the microphone because I'll give him time to think about this one. I'm wondering how creation reflects, if at all, the character of Christ, if you could speak to that at all. And I'm wondering with regard to the scientists, and I relate to Dr. Radner saying that he doesn't know too much about science. I don't know that much about science either, but I'm sure Dr. Radner actually knows a lot about science, but he's just being humble. But I really don't know a lot about science. There's a passage in 2 Peter, and it says, and I'm wondering if this is consistent with science, but the day of the Lord will come like a thief, in which the heavens will pass away with a roar, and here's where maybe the science, you could speak to the science here, and the elements will be destroyed with intense heat, and the earth and its works will be burned up. Since all these things are to be destroyed in this way, what sort of people ought you to be in holy conduct and godliness? So what I'm wondering about is whether, this was written nearly 2,000 years ago, whether there's any scientific weight to Peter saying the elements will be destroyed with intense heat and the earth and its works will be burned up.
Those were for the scientists.
Okay, so you're asking about the end of the earth. So the predictions you would get from astronomy for the end of the earth will be that the sun will become a supernova, and before that it'll actually engulf the earth. The earth will actually be inside the sun, and then we'll go nova, and the earth will be pretty much, destroyed. But the constituent matter that makes up the earth will, the atoms will continue to exist, so the elements, as we define elements, will continue to exist. But of course, in the first century, what they meant by elements wasn't carbon and hydrogen, it was something else. So I think that we'd have a hard time talking. We'd talk different language. So I'd have to think about what was Peter getting at. And I think what Peter's getting at is that, look, the earth is not permanent, and there will be judgment, and the end will come. And he's describing it in a poetic way, but I think it's something we can take to the bank. We shouldn't be relying on the earth and our lives here, because they will, for certain, come to an end.
One thing I would add to that is that there have been a series of historical predictions about what that meant. And if you look at religious tracts from the 1960s, it's always nuclear war. So I just think that indicates, because the Cuban Missile Crisis and these sorts of things, so I think that it indicates that we have to be very careful when we start to make certain predictions, specifically scientifically, what exactly that means, or socio-religiously. And also in terms of the sun death, it's still a long ways away. Several weeks.
That's what your experiments show, it was weeks away?
The question about Christ, I mean, it's a good question, and bringing it up shows that I left a whole bunch of stuff out of what I said. One thing I didn't say, which needed to be said, was that one of the things that took place by the 18th century, is that the so-called two books, and I read from the Belgic Confession, it mentions there are two ways to know God, right? And the first is creation, but then the second is Scripture. The two books were always held together. And there was never any sense that you read one book without the other, ever, until about the 1700s. And you get, it's not that somebody made a decision that you didn't, but you found more and more the arguments were on one or the other. And if you will, the books were not read with one another. One was closed and put aside while you read one book, the Bible. Then you would close that and you'd go to the other book. So I think that it would be hard to sort of read the book of nature using that imagery and say, oh, I can see Jesus Christ and the cross there. Certainly that was never what natural theologians thought. But if you read both, and I think Kepler is a good example, you see. I know nothing about the harmonies of the spheres, but it seems to me that knowing something about the Gospels and hearing the harmony of the spheres, such as they are, one might indeed hear something of the cross of Christ there. But I'm not sure you would be able to know what you were hearing unless you knew something from, if you will, the other book. And so Kepler is a good example of holding the two together, and not just one or the other.
Hi. It's a little past my usual time of highbrow thinking like this, but I hope I can get my question. I hope I can get my question out. Basically, about religion, I really haven't read the Bible, but I did read Northrop Frye's Words with Power, and basically he in the book he talks about the fact that he doesn't take the Bible literal. He says it's all full of metaphors and symbolism, and that basically, all the major figures in the Bible were neurotic, psychotic, borderline schizophrenic, which he's gone out of his comfort zone into psychology. But basically, in Howard Gardner's book, Leading Minds, This Year of the Brain, he talks about how Moses is like Oppenheimer, because basically you have Moses, who's got to explain to all his people, that he had this flaming bull telling him what to do, and he, I don't think he expected anybody to believe him. So he had, Gardner says he had his brother go out and explain it to the people, and like Oppenheimer, he was Yeah, at Harvard, they did a psychological evaluation of Oppenheimer, and they said he was neurotic, psychotic, and possibly a schizophrenic. Yeah, basically, over all the generations, how do you judge the leading minds of from ancient times until now, when they're all trying to lead the civilization into the future, especially in physics. You have Stephen Hawking trying to talk about religion, and everybody's more or less not paying, they don't think he should talk about that.
Are you asking who we should believe?
Well, I'm asking, how do you expect this panel to, get into areas of belief when, even the people who are trying to lead into don't really...
What I tried to do in my presentation was give people an idea of where physics is and where physics isn't. I think I spoke from stuff I know about, so that's all. Okay.
We'll go to the next question, actually.
Talk to me after.
Yeah, we're going to have a reception after, so there's going to be lots of time to discuss, but we'll just keep moving to the next question.
I'm wondering whether all of you have fallen prey to the fallacy of complex question. That is, starting with Ephraim, if you believe it, you will see it. In other words, when you ask, what can we know from nature about God, you're already presuming the existence of God. Your questions really aren't genuine questions because you've assumed the reality of which you're now looking for evidence. Am I wrong in interpreting it that way?
No, I don't think you're wholly wrong. I mean, I think that was precisely to keep to the figure I used, Montaigne, that there's no way to move simply by looking at something and calculating something to a belief in God.
But the point then, Ephraim,
but
is that...
Let me finish. And then, on the other hand, there is, I didn't get into this, but from his point of view, and I would agree with this, there's a kind of interaction. There isn't a unidirectional way in which people come to conclusions, and either of belief or of logic. And the two sides play with each other. That is to say, the descriptive and the believing side.
No, you're wrong, because in logic there's a way of getting to an answer, and in science there's a way of getting to an answer, it's evidence. And what you seem to be telling me is that if you look at nature long enough, already having the belief, it will be revealed to you as it's revealed in Scripture.
I actually believe that, but you don't. And one could go to predestinarian discussions to explain why, but in this case, I don't think that would actually be accurate. It's a question. We'll leave that aside for a moment. We'll talk. We've talked about this before.
Do you want one more question?
I was actually intrigued by a common theme that I saw in all three of your presentations, which I think is quite interesting, and I'd perhaps label it the human factor. And I saw that especially, in the idea, like, do humans automatically have this design tendency? And then in Ephraim Radner's talk about sort of how, we actually see some of our own brokenness when we in the natural world as well, and we kind of see like we are a part of creation, and then sort of like natural theology is also looking at humanity. I would even say in Barth's talk about sort of when you're thinking of yourself as a thinking being and trying to imagine like you're actually seeing it from your perspective, can you imagine yourself like the whole, is it possible for multiple universes, to produce ourselves? It's sort of very much coming back to ourselves. And so I guess a question I have for these discussions would be, I think the question would be, can we ever get beyond that human factor? I would think perhaps not. And then thinking that, kind of, which is what you guys have presented, how do we still make truth claims or make persuasive claims regarding design in the universe given that kind of barrier or lens?
Are you directing this to all three?
I think that is a fair observation, and I think you're right in assuming that I'm locating much of my argument in terms of the human. Now the question is, in some ways I think that the question also relates to how much then does the biology or the human explain away what we're talking about. So if humans have this seemingly natural proclivity to view design in nature, does that, when we describe it biologically, does that mean that that design in nature doesn't exist? Or does it explain design? And I think that's an interpretive step both ways. So I think it's an interpretive step when you say, look, we see that humans and children, for instance, always seem to find agency in the world around us. It's just a natural thing, so therefore it's just a biological thing, so therefore there's no design. You can, at the same time, when you say, look, I think you could just as rightly say, look, this is the way we are, and it doesn't we're meant to look for design. And I don't think we can step beyond the human factor. We're always, in my personal opinion as a sociologist, there is always that human contingent. And that doesn't necessarily discount the non-human, but essentially we are bound to that. And that's not a bad thing. It is, my biology is what I am, and that's a good thing. And it's not necessarily, like, to explain something away as biology or to explain something as biology doesn't necessarily negate it or make it evil or bad. That would be a little bit of my response to that.
Yeah, I would really tend to agree with you. The only thing I actually know exists is me, to go back to Descartes. And so I'm trying to explain my experiences. And so how can we talk about the universe without myself? I assume logic works. Probably does. Seems to work effectively. But that's based on assuming that my memories of what happened 5 minutes ago are even remotely accurate. Right? And there's like all these assumptions that we make implicitly and explicitly. So the idea of trying to somehow come up to some sort of objective understanding of the universe acknowledging that they're assumptions.
I would agree with that. And the mentioning of Descartes, I think, is helpful. I mean, that is to say, he struggles trying to get beyond himself and finds that he can't. And then he asks the question of what that means. And I think people can come to different conclusions as to what it means that one can't get beyond oneself. He comes to a conclusion, which some find persuasive and others less so, that raising that question itself opens up the reality of God to him. I am persuaded by that. Not everybody is. But I don't think it's something that one can prove right or wrong, actually, because it's at the threshold of the very notion of there being some kind of reason of any kind. As you said, logic seems to work, but there's no, who knows? So there are all kinds of possibilities that one could imagine, as Descartes does, that could undermine that. So I agree. But I would say, I guess my point is, I think there's actually something powerful, potentially, about recognizing that consciousness-centered character of human life.
Steve, would you like to come up and make any final comments? You mentioned some reception, and then I'll thank the speakers.
We're going to have a reception in the reading room, which is just down the hallway near the entrance. You're all welcome to come, and the speakers will stay for a little bit, I'm sure. And yeah, just thank you for coming out and supporting our event.
And thank you very much to our three speakers. Let's give them a good hand.